as well as being able to draw curves, you have to be able to recognize how the function has been transformed, or even sketch what we call a transformation. Now, what transformed or transformation means is, for instance, we might have the equation x plus 1, the function x plus 1, and it's been changed into x plus 2. So what have we actually done with that? Well, we've added 1 onto the function. So our starting function was x plus 1, and if we had that starting function and added 1 to it, we've then got x plus 2. So by changing that formula, we've transformed the formula and need to be able to sketch it or recognize how something is changed in certain cases. So here we've got a function where the function is x squared. So for any value of x, we will get the result of that number squared. Like I said, when we're plotting functions, we're going to call the f of x y. So we'll use the result of the equation as the y-axis. And when we plot this, we get this curve shape, a U shape, what we call a parabola curve. So functions with x squared in them, or at least x squared is the greatest power, gives us a parabola shape, this U shape, or sometimes an N shape, which we'll look at later on. Notice, because nothing was added on to the x squared, it touches the y-axis at 0, because 0 squared is 0. So because the function was x squared and not x squared plus 1 or so on, it touches the axis at 0. Here it's changed. Now a transformation has taken place. What has happened to the equation to allow this to happen? Well, our end result has increased by 1, whereas it was on 0 before, or y was 0 before, now it's 1. So in other words, we've added 1 onto the function. X plus 1 has become x plus 2. Sorry, x squared plus has become x squared plus 1. So our original function was x squared. Now we've got x squared plus 1. Just the same as if we had started up by here with maybe x squared plus 5. If it moves up 1, it becomes x squared plus 6. So we're adding 1 onto the function. Notice how the plus 1 is outside of these brackets, because it's outside, it's the y that's being affected by the plus 1, not the value we're putting in. So if we add 1 on outside the brackets, the graph moves upwards. A note to remember is that when we're looking for an answer to this equation, there is now no answer where the function is equal to 0. Also, when we've got the function of x and we take away 1, that's going to move the graph downwards. And another note at this point is that there are now 2 answers to the equation where the function of x is equal to 0. So in this case, where x squared minus 1 is equal to 0, the answer would be by here and by here. So next, the equation has moved to the left. What have we done to the function to move it to the left? Well, in this case, the answer for x is 0 has come sooner. It's come when x is minus 1. It's reaching the 0 point of the y-axis at an earlier point. Similarly, it's touching the 1 value of the y-axis, or it's reaching the 1 value on the y-axis, a unit earlier than it would have done before, because before, in the earlier equation, it reached the y equals 1 when x was equal to 1. So in other words, if we're moving the answers 1 earlier, we've actually added 1 to the value of x. So at the point of where x is 0, instead we're doing x is 1. Where point of x is minus 1, we're doing the value of x is 0. Now, don't worry too much about understanding that concept. The important thing is to remember is when we add 1 onto the value of x, not onto the value of the function, then it moves to the left. And if we take away 1 from the value of x, it moves it to the right.